Well, first of all, welcome everybody. It's great to see some, just, you know, all these familiar names, and in some cases, faces and videos and stuff like that. So this is really great. I have a really nice mix of people from both Cabrillo and UCSC here, so that's really nice, and a lot of people watching the recording. So just welcome. So first of all, let me just tell you that there is no obligations or any requirements or anything you need to do. I don't take, this isn't like a regular class or anything like this. This is just completely, you come and go as you want. You watch a recording if you want, not watch a recording, it's all good. Okay. My one of my recent interests has been in network automation and programmability. I'm going to talk about a little bit this tonight. Well, that's really what we're going to talk about tonight is what our focus is going to be, or begin to look at what our focus is going to be, or my focus will be anyways. And I really appreciate you being here. It forces me to really kind of, I've been putting together materials for almost a year now. I'll talk about a project I worked on with Cisco that you'll have access to. And mine is kind of a deeper dive into a specific area of this. So let's go ahead and get started. And let us, shout out to, I've been wanting to put this class together for a while and get it started. I know a lot of you have heard from me from last semester even. Or last quarter that I was going to be doing this. So it was actually Jarita, thank you for sending me that email and going, Rick, are we still doing this? And I'm like, yes. So thank you for that push. It wasn't a push. It was just, I needed to send out the email. All right. So here we are on, you can see my Canvas screen. I know a lot of you are thinking, well, I didn't see it on Canvas. So let me put this in the chat. And this is, you should actually just have access to this link. And I'll send it out in an email. But here's the link itself is, I think it's the same, no, it's a different link than what shows here. If you click on that link, that should bring you to the Canvas page. If anybody wants to try that, let me know in the chat. If it doesn't work, I'll figure it out. But I tried that link, but I don't think I have a login. Is there? Wow, that should allow anybody. It doesn't have to be Cabrillo. So let me fix that. Let me find out what's going on. So thank you. It's asking for username and password. It wasn't supposed to. Okay, so let me fix that. So thank you. All right, good. We won't need it for tonight, but I will get that fixed. All those people at Cabrillo told me that it would work for anybody, non-Cabrillo. So if we take a little break, I'll fix it. I'll work on it later. All right. You got the Zoom information, so that's the most important. And I'll send out an email to everybody about the recording link as well. All right. You've also got, you'll also notice that as you enter, it might be asking you to be admitted. That was my mistake. I'll fix that. So I'll be clicking admit a lot. So I'll fix that. So you come and go as you want through this. So in Canvas, when you eventually get access, okay, the Zoom information is right here. I'm going to talk about this Cisco Networking Academy DevNet course in a moment. I'll put the recordings all right here. I'll also email it out to everybody. Okay. Don't worry about these. I don't even have the link. You don't even see these. Even if you're on Canvas, you wouldn't see this right now. But I'll be talking about these VMs that you'll have access to. Again, there's nothing required. that you need to do, okay? But I will be giving you access to a couple of VMs, a Linux VM that has some stuff already preset, and also a VM for Cisco CSR 1000 router. And the two VMs are very cool. I'll talk about this on another week, or in a couple of weeks. But you'll actually have on the Linux virtual machine will be connected to the Cisco router, and you'll have tools on both of these that you'll be able to do some automation and programmability from the Linux VM onto the Cisco router. So just like what we'd want to do in the real world. And yeah, anybody's welcome to join the call. Yeah, anybody's welcome to join. So if you have somebody, just send them the link, the Zoom link. Yeah, no problem. I just asked for people to let me know so I could add them to something I'm going to talk about, the Canvas page. And so, yeah, invite your friends, family, neighbors, whoever you want, loved ones, or maybe people you don't love so much, you want to get back at, invite them as well. So I'll talk about these VMs more later. And by the way, I'm not assuming any knowledge beyond basic networking knowledge. If you've never used a VM before, don't worry about it. Okay, when we do the VMs, I'll walk you through it. Okay, so everything will be, I know I have a wide range of people out there, various skill sets, knowledge, courses. So all I require is that I require nothing, but prerequisite is just basic networking knowledge. All right, let me talk about this course right here. And all of you should have access to this. This is the Cisco Academy DevNet course. So you should have gotten an email. Check your spam. That's another reason. That's one of the main reasons I asked for your email, so I can register you in this class. And when you register through the Cisco NetAcad, become part of the Cisco Networking Academy, okay, you should see this course right here, Seminar on Network Programmability and Automation. Okay. And I see several of you logged in already to it. Let me just mention briefly what it is. So you'll go here and we'll launch the course. And I'm going to go here to where it says modules. And then I'm going to go right here, and I'll activate all these module group exams, just in case anybody really wants to take them. But I'm going to go right here to DevNet Associate Course. They make you click 100 times here. And then here where it says load DevNet Associate Course. Okay, oops, I had it already. Okay, that's what you'll see here. Okay, so before I talk about the course here, let me open this up. So when you click on this link here, by the way, what you're going to see is a link to netacad.com. Your username and password is the email from Cisco. You'll select the network programmability and automation. If you want to learn how to use this course, how to navigate, okay, I made a little video that actually has to do with another course, but it's similar navigation that shows you just how to navigate this course. How to navigate the course, takes you step by step. It talks about how the course index. So you can select, I want to see any of the, animations. Are there many animations? I don't think there are any. Videos, here we go. Here's some videos, things like that, labs. Okay. Let me talk a little, let me close this. So anyway, this video here will show you how to navigate this course. You can open up different, I can go down to here to understand understanding and using APIs, go to introduction, click here, takes me here and walks me through it. Okay, so let me explain a little bit about what this course is. This isn't what I'm doing per se. Really, if you want to know what I'm working on, what we'll be doing is really down here in module 7, really down here with module 7 and module 8, and not even all of these, some automation tools. I'll be doing some Ansible, but down here in 8 with understanding programmability, Yang, NetConf, RedsConf. So I'll talk about, but this is really our focus. So let me talk about what this course is real quick. Where's the book here? Okay. So if you look in the video here, this Cisco recently, about a year ago, announced a new certification, Cisco Certified DevNet Associate. And really what they're trying to do, and there's kind of a long history of this, that this is really a way of bringing in software development techniques and methodology into networking. Okay, in software development, some of you might have heard, is called DevOps. And so networking has been trying to apply the same kind of methodology to networking. Cisco created a certification path called DevNet, and it's got different levels, just like the other ones: associate, professional, and expert. So this course here that you are seeing is actually from their course that they actually charge customers for, I think like $99 a month to use. Okay, you're getting access to it free. We made it part of the Cisco Networking Academy, and I worked on this course here. We modified just barely any of it because we just didn't have time. We mostly worked on the assessments, and I mostly worked on the labs for this course. And I'll be showing you some of these labs throughout, but I will give you access to everything for this course. I will even give you the instructor lab manual for this course. So you'll have that. We're not going to go through all this, but you have access. Okay. This course is a lot of things. It's really as much for those people interested in software development and doing software development as it is for those people in networking. My take isn't too much on the software development side for what I'm interested in. But so you'll see, so I'll let you look through this stuff, but you can see it's a lot of, they talk about, Linux, Python, DevNet overview. That's the Cisco side. I'll let you look through this stuff. But here's the software development, get into Git and GitHub if you've ever used that, and all that kind of stuff. So yes, this course is designed to prepare you for the DevNet Associate certification. I would probably get this book though. I'll just be honest with you. I'm not a big fan of how this course is written. I don't think it does a very good job of explaining most things. I'm not trying to be critical. My whole team felt the same way. We just did not have time or the funds, that's my Cisco team, to rewrite this. I hope someday we can, but it's really good if you already know a lot of this stuff. That's my take. The only part that we rewrote, and that I was given the task of rewriting this because their networking fundamentals was horrible. So anyway, I hate to criticize, but it was just, but hey, it's free. It's free. Okay. We'll go with it. So anyway, I am not going to be using this. I will adapt some of the labs. I will give you access to everything. Okay. All right. Any questions on that before? You should have gotten a link to it. You know, I think I've given you access until June 30th. Okay. So, and I'm happy to extend that. All right. So I think I can only make a class last a year. So I'm happy to extend the lifetime of this class in case anybody ever wants it. All right. Any questions on that? All right. Okay. Let's see, make sure there's nobody waiting. Nope, nobody in the waiting room. All right. All right, so let's get into what I want to kind of talk about tonight. We're going to come back to the VMs and stuff. I'll kind of show you where we're headed. So I'm going to talk about network trends tonight, because really, why are we doing this? And I've got some links to some videos I'm going to talk about. Then really our focus is probably the next week or two, I'm going to talk about data formats. And if you don't know what any of this stuff is, perfect. You're in the right place. But JSON, YAML, and XML. And then I'm going to talk about the Yang data model. Then we'll talk a little bit about APIs. Okay, not from a software development standpoint, but really what are APIs and how do we utilize them? Okay, and then this is where I'm going to spend the majority of our time, is probably on these two topics, netconf and restconf. And if you don't know what those are, don't worry about it. We will get there. But that, along with Ansible, are ways that we can automate and program network infrastructure devices. And that is basically the focus of this seminar, okay, is on, in the world of networking, and I'm going to be talking about this in a moment, we've been doing things a certain way, and that's not going to work as we move into the future, especially large enterprises and service providers. We need a new way of how we implement, configure, monitor, troubleshoot networks. And this is how we're going to do it. Well, this is one of the ways. Okay. These are the tools. Okay. They make use of APIs and the data formats, is why we talk about that first. All right. So let's go ahead and get started. I will get us out of here by 6:30. Okay. So if you enjoy your dinner, well, or whatever, well, and I'll get started. Luigi's had his dinner, so he's asleep because I'm about ready to start talking. Funny how he just falls asleep as soon as I give a lecture, just like everybody else. Nah. All right. Networking trends. Okay. So what this course is and what it isn't. There's so much going on in the world of virtualization, automation, cloud, programmability, DevOps, and all this. It's massive. And I'm going to talk about some of those topics today, but really our focus is going to be narrow. Okay. So we will not be covering cloud, DevOps, application deployment, and those sorts of things. What our focus is going to be is on the network infrastructure. Okay, so the plumbing, the routers and switches, or other infrastructure devices. How are we going to transition from our traditional way of implementing and managing this network infrastructure, command line interface, to a more faster and more responsive and really a more accurate way of doing things. Okay, so these are two of my favorite books. A lot of books out there, but if you really want two books on what the focus of what we'll be doing, these are two great books. Okay, Network Programmability and Automation. Actually, I've got them backwards here as far as this is the O'Reilly Network Programmability and Automation book. Excellent book. And Network Programmability with Yang. This Yang, NetConf, RESTConf. And that's really what these two books focus on. Yang, NetConf, RESTConf, and this O'Reilly book does a little other stuff like Ansible too. Okay, so in traditional based networking, okay, it's all configuration based and it's a world of protocols. Okay, wow, I mean, that's one of the things that, people like myself, it's all about the protocols and more of these protocols. And this is just not even the tip of the iceberg. Okay, on all the protocols that are involved in networking. People think sometimes, oh, yeah, it's networking. I get this sometimes from certain groups that think, oh, yeah, so network engineering, that's like, you connect printers and fix printers. First of all, I can't fix a printer. It's beyond my skill set. But, the concepts of networking, network engineering, and that is very important. But the ability to apply those concepts is equally important and equally as complex. So the ability to do both is very important, understanding the concepts and the theory and to apply it, because these are complex systems that got to work together. All these protocols got to figure out to work together, and sometimes they don't play nice. Okay, this is Carl, the network engineer. This comes from a friend of mine, Hank Preston, his presentation. He always uses Carl. Hank Preston, I'll talk about here. I think I've got maybe or I'll show you later, his videos. In fact, let me make myself a quick note because I do want to show you that before we go. But he's been kind of the evangelist for Cisco on DevNet for many years. So please remind me to show you, and I'll put the link in Canvas and make sure everybody gets access to Canvas for his videos. But one of the things he talks about is uses Carl, the network engineer. And Carl's programming skills are kind of limited. Maybe some scripting, minor scripting, but what Carl is really proud of is all the protocols that he does. And that's been kind of the world of networking. So what a network engineer does is network device, it's configuration and more configuration and more configuration and more configuration. We spend, and we spend a lot of time configuring networks. And then when we're not actually doing the configuration, what do? We're troubleshooting our configurations. Okay. And that's a problem. First of all, this is hugely time consuming and not very accurate and may not even get to what we want the network to be able to do. We're just hoping it does what we intend it to be. And I'll talk about that towards the end. The network has changed. Okay. Years ago, it was very simple. You had routers and switches and servers and end devices. And you did routing protocols and spanning tree and things like this. But the network has changed. It's gotten more and more complex, more and more devices, more and more protocols, more and more requirements, and more and more things we've got to manage. So traditional based network engineers, the whole idea of automating what they're doing is like, yeah, that sounds great, but I just don't have time to get there. Okay. So we've got to start finding time to get there. Okay. Traditional based network, we have high capital expenditures. What does that mean? These big box multi-layer switches and routers and firewalls and everything we buy, they have a life cycle, about 3 years. And then you buy new ones that are bigger and more expensive. Okay. These are proprietary hardware and software solutions. Now, let me say, this is not necessarily a bad thing. And the whole idea of having these proprietary solutions like Cisco and Juniper and whoever, and keeping it that way, that's a lot of companies are going to want that, especially smaller companies, smaller enterprises, medium enterprises. They're not going to have the staff to to be able to automate and program and that. So this is going to be here for a while, not going away. Okay. High operating expenditures. I mean, configurations, the time it takes to configure devices, support agreements, licensing agreements, the complexity of all this, and all the troubleshooting. The vendor network operating system, you get everything in the network operating system from a vendor. What you need and a lot of things you're never going to use. I mean, like Cisco, iOS. You might be running OSPF and doing some static routes, but they're going to give you BGP. They're going to give you EIGRP for IPv4, EIGRP for IPv6. They're going to give you RIP that nobody uses anymore. They're going to give you ISIS. You're going to get everything. And you're paying for it all, but you're just going to use OSPF. Traditionally, they haven't been customizable and not allowing you to program or automate. So it doesn't give us much flexibility. The need to change, to automate, to have more choices has been customer driven, hasn't come from the vendor per se. So this is also from Hank, his 4 ages of networking. So in the early years, we had the Stone Age, spanning tree, VLANs. I hate to say I'm pre-Stone Age. I mean, I remember when spanning tree and VLANs were new. Gosh, that's sad. Bronze Age, routing protocols, WAN design, IP-Ageddon. That's all of a sudden IPv4 and then IPv6 started coming into play. Then the Renaissance. You started hearing terms like SDN. I'll talk about that tonight. It means a lot of different things to a lot of different people. Open flow, controllers, VXLANs, white box. So that's kind of where we are, and where we're moving to is really this programmable age. Okay. So get ready for the buzzwords. All right. And believe me, if your eyes glaze over when looking at this stuff and go, I don't know, what are all these things? Join the crowd. Okay. You know, the nice thing is you're not Carl. I come from a world of Carl, the network engineers. Okay. And you're all learning the new stuff. You're learning, you're learning some programming. You're learning a lot about this stuff. And we don't know what's going to stick. This is my point of view anyway. This is like the pioneer days. Like the pioneer days of networking. Pioneer days of networking, used to show the network. Let me show you this real quick here. This is what I had on protocol. Let me type here. How do you spell protocol? When I was first teaching, where is the? Everybody had this in their classroom. We used to give them away to students, these network protocol maps. Let's see if I can actually, oops, sorry. Let's see if I can do this here. I don't know if you can see this, but these are all different suites of protocols. We had Apple Talk, Sun, IBM. Trying to read some of these. I know we had Microsoft, we had Banyan Vines, Apple Talk, Novell Netware, all these different protocol suites. Okay, and we had these protocol charts that actually would show all the different suites. Okay, and learning all these different, and what stuck? One, TCP/IP. Out of all these suites of protocols. And by the way, down this lower layer, let's see if I can show you. These are all the layer 1, layer 2 protocols. I know you can't see this, but they're like Ethernet, but there was ISDN, X25, and all these, which have all gone away, except Ethernet. Okay. So anyway, I don't know what's going to stick. We'll find out. So let me get past this term. SDN, software defined networking. That is probably the most I don't want to say overused word, but it has gotten to the point where nobody really uses it anymore to explain anything, because it really means so many different things to so many different people. But kind of overall, and really kind of where we are moving towards in a lot of this world of software-defined networking, is to do something that we call abstracting or separating the data plane from the control plane. Now, if you don't know what that is, that's why Rick is here. Okay. Let's talk about what the control plane is first. So networking devices have two planes. Actually, there's a third, management plane too, but control plane and data plane for forwarding information. The control plane, as you can see here, let me get past here. All right, there we go. The control plane, this is where your routing table is. Okay. So if you are running, let's say OSPF, you are sharing information with other routers, and you are populating via OSPF, the OSPF neighbor table and the OSPF link state database. That information OSPF uses, it runs an algorithm called SPF that then populates from this information here, the routing table. Okay. You might have static routes that go into the routing table, and you might have also, remember the ARP table, or in IPv6, it's called the neighbor cache. This is the next hop IP address and its layer 2 MAC address. Okay, so all that gets done in software in the control plane, and this all gets processed by the CPU. Okay, so that's the control plane. Okay, it's kind of the brains. That's where all the big thinking is happening, up in the control plane. The data plane is where the forwarding happens. Let me kind of get through this here. Went too far. The data plane is hardware. Okay. This happens in special chips called ASICs, application specific integrated circuits. And basically what the role of the data plane is to actually forward the packets. So the packet comes in, okay, then remember the router's got to look at, okay, where's it going to go? What interface am I going to send it out of? My routing table will tell me that. Oh, then I got to figure out, okay, I know I need to send it out faster than Ethernet 02. That's what my router table told me. But you know what? I've got to encapsulate this packet in an Ethernet frame to the next hop. I got to look in the ARP table to get that information, or do an ARP request and get an ARP reply to get the MAC address of the next hop. Okay, so that's the kind of the data plane. But what we want to do is let me actually go there. I'm going to talk more about this in just a moment here. Okay, let me show you how things used to work. So what would happen is a packet would come in, go up to the router would send it up to the control plane. Would look it up in the routing table, find in the ARP table what the MAC address is, and then it would send it out its way. And it would do that for every packet. Now, the problem with this is all software based. Okay, this is analogous to if you had to do a problem longhand, do the calculation. And what if somebody gave you the same problem one after the other, but the same problem? This is analogous to you figuring it out every time because you can't remember anything. So you have to do the math every time, although it's exact same problem. So this is as if we have 5 packets all going to the same place. Okay, same source and destination addresses. They're all going to the same place, but the process switching, the software, the router has to send it up to the control plane to figure out what to do with it. So the next evolution of this was something called fast switching. Fast switching said, okay, let me see this first packet, and I'm going to figure out what to do with it. Look it up in the routing table, look it up in the ARP table, and then I'm going to store that information in fast forward cache. And I'm going to do that in case I get more packets going to the same place. And if I get more packets going to the same place, you know what? I don't need to send them up to the control plane. I've got that information already. It's analogous to figuring out a problem by longhand, in math. And then if you get that same problem again, it's like, wait a minute, I've got the answer. I don't have to figure it out again. All right. Now we're going to get into what Cisco calls Cisco Express Forwarding, but this is where the control plane and the data plane work more tightly together. Okay. In this case here, what happens is we have the routing table and the ARP table. Okay. So the routing table is what interface am I going to send it out of? And the ARP table is basically how do I know what interface it goes out of, but I got to encapsulate this in, let's say, an Ethernet frame. What's the MAC address of the next hop router? Well, what happens is the routing table pre-populates something called the FIB, forwarding information base. The FIB is basically a mirror image of the routing table. And then the ARP, or neighbor cache in IPv6, populates something called the adjacency table. And these two, that's Luigi slurping, by the way. These two work together. So if it says, the FIB says, I need to send it out fast Ethernet 02, the adjacency table says, no problem, the next hop MAC address is 001B. Encapsulate it with this destination MAC address. That's how they work together. So what Cisco Express Forwarding does is this information is pre-populated. So the information never has to go up to the control plane. If there's any kind of change in the routing table or ARP table, that information is automatically pushed down to the FIB and adjacency tables. So this is like the router solving every possible problem that it can imagine ahead of time and having it all ready. Now, are there times that things have to be pushed up to the control plane? That can happen. I won't go into those circumstances, but those are minimal. Okay. So I just wanted here to just give you a little idea of the control plane and the data plane, because you're going to hear that throughout, whether it's in my stuff, although we don't really talk too much about what we're going to be doing, the control plane and data plane. Okay. But whenever you talk about SDN, they're always referring to the control plane and data plane. This is the Cisco Express Forwarding model. Okay. Okay. So in traditional based networks, okay, we talked about the control plane and the data plane. Really what the network engineer does is when they're programming the router, what they're programming is the router's control plane. Okay, they're configuring OSPF, they're configuring EIGRP, they're configuring access control lists, they're configuring routing policies, they're configuring whatever. Okay, but it's all that configuration just really has to do with manipulating the information in the control plane. What SDN does, and I'm going to say generic SDN, that's my own term, is it actually, what it does is the idea is to separate the control plane from these devices and put them on something called an SDN controller. Now, we're not going to be getting into SDN controllers, I just want to give you kind of what the generic SDN concept is. And then what the network engineer does is not using the router command line interface, but using software program, writing programs, or however it's going to be done. Cisco has their own controller. It uses a graphical user interface. It's called DNA Center. They also have other ones as well, APIC EM and others. But anyway, it's basically a GUI that the network engineer uses, and then that information actually gets from the control plane, gets pushed down to the data plane on the appropriate devices. Now, I said generic SDN because really what Cisco and other vendors do is they keep the control plane here. Okay. And basically what it does is copy the necessary, instead of when something comes in, and if it's not in the data plane, it's got to go, what they're trying to do is keep the router from having to talk to the control plane too much in the SDN controller. So what Cisco and other vendors do is pretty much copy the necessary information from this control plane to the control plane of the device. I won't get into the specifics here. It's really not that important at this point and what we're going to be focusing on. But this is what maybe a lot of you in other classes, especially at UCSC, when they, you perhaps used OpenFlow and things like that. And I'll talk about here's OpenFlow. So OpenFlow is was written by Martin Casado and previously at VMware. What did I do here? Okay. It was actually served as really the first major protocol in the SDN movement. So that's why it's gotten so much attention. It wasn't the first one to do this, but it basically, as you can see here, we have a SDN controller here, and then the data plane on the devices. And then it's basically the protocol that decouples, separates the device's control plane from the data plane. Okay. And that's just kind of in simplest terms. The control plane is the brains, the data plane is the ASICs that perform the forwarding. Okay. But again, this is not what our focus is going to be on. So what is SDN and what is Rick's focus going to be on? Okay, SDN is like cloud was several years ago. It's a whole bunch of things. Okay. And again, what our focus is going to be is really how do we automate and program network infrastructure devices. And that's just one piece of all this. Really, what we're going to be looking at is network automation. And that's pretty much going to be our focus, and device APIs somewhat. Okay. That's what our focus is going to be. But I'm going to talk a little bit about what some of these other things are real quick. Everybody doing okay? Everybody all right? Anybody need anything? Need something to drink? Make you dinner? You don't want me to make you dinner. I'd love to, but that's not going to turn out well for you. All right. So virtualization, I'm going to talk more about virtualization later, okay, when we do the VMs. But virtualization is basically creating a virtual rather than actual version of something. So, many of us, have run VMs on our computer. So, I have a Mac, okay, and I run not VMware. Actually, I use something called VirtualBox now. I still have VMware. I don't use it so much anymore. But we can run different operating systems on our computer, like having multiple computers, but all using the same hardware. I'll talk more about this a little later. In networking, network functions virtualization. So there's always, wait a minute, what's SDN and what's NFV? I think that's probably, you Google SDN and NFV and you're going to come up with 1,000 different people trying to explain the differences. And you're gonna get a lot of different answers, I think. But anyway, NFV is basically taking the functions, and I'm going to show a little video on this, that are traditionally deployed in hardware. So a separate router, separate switches, separate firewalls, and deploying them in software. So this includes routers, firewalls, load balancers, all kinds of stuff. Go ahead with video. Yeah, I get the video coming up. So again, the traditional model is vendor-based solutions, proprietary hardware, proprietary operating system with 3-year change cycles. And every 3 years, you're getting bigger, more expensive, more devices, everything, you're implementing more protocols, you're needing more and more Carl's. Carl's head is exploding. So you'd buy, this is another look at it. You'd buy the vendor hardware. It comes with the vendor proprietary operating system. It comes with the protocols and everything that it does for you and more, probably more than you need. And you're gonna have to buy licensing and support for it. Okay, that's not necessarily a bad thing. I mean, there's a lot of institutions that want to continue this route. It's a very safe way to go. Okay. And each cycle, you're buying more ports of everything. Everything's costing more and more money. Okay. Service providers and large enterprises are the ones really feeling the effects of all of this. Their costs are skyrocketing because you're talking about thousands of devices. Thousands upon thousands of devices, and their operating and capital expenditures are going through the roof. So in 2012, a group of the leading telecom network operators got together and said, we need a new way of dealing with this. Okay, we need to come up with being able to manage, to implement, to have our networks operate them at a fraction of the cost, also be more responsive. Okay, when you get in a whole new slew of equipment, the hours it takes to configure these devices, put them into production, and hope everything works. It's not easy. It takes a long time. We want to make it more scalable. Because as we grow, as you need more and more devices, that's just more and more hours of doing the same repetitive tasks. All right, so let me take you to a video here. Just 2 minutes of this video. Whoops. What did I do?
Virtualization, a new path for telecom networks to keep up with the insatiable demand for bandwidth. 7 of the world's top network operators have released a white paper advocating for a revolutionary way of building out and running networks at a fraction of the cost, at a blistering speed to market, with astonishing scalability.
That was a sea change in the whole world of telecom in the mobile side. Folks saw the groundswell of operators who were now behind this concept.
This was multiple large service providers saying we can no longer compete and drive our businesses using old school IP infrastructure. We need software on standard hardware in order to advance our strategies and advance our infrastructure. So if there was a shot heard around the world in the service provider space, it was in October 2012 when the readout of that paper happened.
Traditional theory says each...
Okay. So I give you links to all these. And again, I make sure everybody gets on Canvas. So, so if you want to watch more of any of these things. So this is part of a TIA, they're EIA, TIA, they're a standards organization that they did on network, the Network of the Future documentary from a few years ago, but still good. I want to show you another one on just, kind of giving examples of network functions. So virtualization, I'm just going to show part of this video.
Many service providers go beyond simply providing network connectivity for their enterprise customers. They also offer additional services and network functions like network address translation, firewalls, encryption, domain name service, caching, and others. Traditionally, these network functions were deployed using proprietary hardware at the customer premises. This approach provides additional revenue, but deploying multiple proprietary devices is costly and makes upgrades difficult. Every time a new network function is added to a service, a truck roll is required to install the dedicated hardware. Service providers began exploring ways to reduce cost and accelerate deployments through network function virtualization. Network function virtualization, or NFV, decouples functions like a firewall or encryption from dedicated hardware and moves the function to virtual servers. Instead of installing expensive proprietary hardware, service providers can purchase inexpensive switches, storage, and servers to run virtual machines that perform network functions. This collapses multiple functions into a single physical server, reducing cost and minimizing truck rolls. If a customer wants to add a new network function, the service provider can simply spin up a new virtual machine to perform that function.
Okay, we'll leave it at that. Okay, so this is going to be kind of the beginning of our focus, is starting with learning a little bit about APIs and data formats and stuff. So, part of this whole movement from, hey, we can't just do things the old way with command line interfaces on all these devices and all this is that it's just not going to cut it anymore. We need to move towards something different, or at least have that option to do this. Okay. CLI has severely held back being able to be more responsive to the customer's needs. And all of this, things with APIs, that I'm going to talk about here in a moment, is it uses something called structured data. So a major pain point for using anything with a command line interface. So here's a Cisco show interfaces fast Ethernet 00. And a lot of good stuff in here. The programmer, whoever wrote this many years ago at Cisco, they decided, oh, we're going to write it like this. This is going to say that the interface is up. Oh, here's the MAC address. Okay, address is blah, 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 blah. Then I'll start a new line here. Here's the maximum transmission unit, blah, 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 blah. I'm going to put, whatever information I want to put in here. It's all right, all here. It's full duplex. So, Carl and Rick, they know where to look and they're very comfortable with this. But the problem with this is if you're writing a script to say, I want to do some automation here, and I'm going to get the output from here and from 100 different other devices, and I want to pull all this information like the MAC addresses, let's say. Well, you got to write a script to kind of parse this information. And I'm getting into programming terms here, but it's basically not having to know what line it's on and where exactly it begins and where exactly it ends. Okay. Well, that might work if first of all, if you have all Cisco devices. Okay. Also, one of the problems is what if Cisco, and they do this, all of a sudden changes the output in a new release of the operating system. So things look a little different. Things are a little off or not in the same place. Now your script is broken and you've got to rewrite the script. And again, this script only works for, in this case, Cisco. Okay. So the idea here is we want to move to something called structured data. Why can't you give me this information, but in a format that I can easily use? Okay, so data formats. We see this with HTML. That's a structured data format. Okay, we have beginning header level 1, end header level 1, begin paragraph, end paragraph. Okay, So some common data formats that we use in the world of networking is JSON, XML, and YAML. Okay, and we actually do use all of these. Okay, and we'll talk about these in our next go around in 2 weeks. So what is a data format? Okay, it's similar to like a programming language in that it has rules and structure. Okay, and it depends on the data format itself. Each one is a little different. They all have syntax. Some use brackets, some don't. Some use white space and indentation, some don't. Some use quotes, commas, whatever, some don't. It all depends. And it's how they're going to represent characters, strings, lists, arrays. And it's all about this idea of a key value pair. I'll show you an example of this in a second. But a key is like, what are we looking for? A type, like an interface. And what is the value of that? So let me show you. But this is what the structured data does. And we're going to be moving from looking about structured data. Let me give you an example here, JSON. And then we're going to talk about how, well, I'll get to it in a moment, something called Yang. All right, so here's iOS output. Oh boy, gigabit. This is from a show IP interface command. Show IP interface command, it gives me the interface. Protocol is up, IP address. Okay. That's a nightmare to try and find that information. This is great human readable. And that's what it was initially designed for us to read, for Carl, Rick to read, okay? And that's what it was designed for, make it human readable. But it's not very good for machine readable, not very good to get a program to look for this information. If you've ever done anything with spreadsheets or databases, okay, we list information in a structured manner to make it easy to manipulate, make it easy to sort, make it easy to filter. And that's what we do. We can get that same information in a JSON format, okay? And it actually gives us in these key value pairs. So the name, what's the name of the interface? Gigabit 000. Okay. What's the description on the interface? Wide area network. Is it up? True. That means it's up. Okay. What's the IPv4 address? What's its subnet mask? Wow. That's a lot. You know, if we had data like this, we can do things with this. We can either use programs and tools that can utilize this information from many devices or from this device, and we can do something with it. Maybe I want to change the IP address. Once I see this address, I want to modify it. We're going to be doing this. Okay. Let's see. Yeah, I'll come back to that here in a moment here. All right, here's an example of the same with YAML and XML. Okay, so the information is the same, but that's slightly different. Look at YAML, it uses indentation. Okay, here's the key value pairs, got them in different colors here. XML, that looks a lot like HTML, doesn't it? Okay. And we're going to see that different programs will tend to use or can use different things. YAML tends to be a little bit more human readable. So we have some automation tools that prefer YAML. Here's the key value pairs. Okay, APIs, application programming interface. It is an API is software that lets other applications access its data or services. Have you ever gone to an app and it says, oh, do you want to log in with your Facebook or a Google account? That's an API that does that. You know, here's on my phone, I use FlightAware. Okay, my friends come in from Italy. Okay, this is an app that is using an API to access flight status from various airlines. Yelp Yelp uses a Google Maps API to get location information and show Google Maps. Okay, we'll play around with the API stuff coming up in a few weeks. Okay, here's an example, Expedia. Expedia, uses APIs to interact, different airline APIs. So when you're looking to go from San Francisco to Rome, it gives you flight information from various airlines. So you don't have to just go to each airline's website to get that information. Network automation. So this is where we're going to end my focus. Network automation. This is a process of automating, configuring, managing, testing, deploying, operating of physical and virtual devices. So we're going to look at Yang. Yang is really a data model, but it's used by NetConf and RESTConf. And we're going to use Ansible, which is kind of in the group with things like Chef and Puppet and Salt and others. Okay, but we're going to do some Ansible and some NetConf, RESTConf with Yang. Okay. Basically, the idea here is that we want to take everyday network tasks and functions, get them out of the hands of the networking team. Okay, we want a lot of this stuff to be controlled and managed automatically. Okay. So I talked about this already. Okay, all of these components came from the same vendor, and that's not necessarily a bad solution and still is a solution many people want to stick with. Okay, so what about being able to use kind of generic hardware and putting your own software on it? Okay, this is where we get into the world of white box and bare metal network devices. Okay, where the hardware looks more like just an x86 server, kind of like just what you put, your VMs on now for Linux and whatever you're running. Okay, disaggregates, separates the required components. It makes it possible to buy hardware from one vendor, to buy your network operating system from another vendor or open source, and buy your applications, the protocols you want to run on it, from multitude of different vendors or open source. Okay. But again, this takes a skill set. Okay, and not there's going to be those, especially the smaller IT departments, that are not going to have the skill set or the time or the number of people to do this. You look at the world of Facebook, Google. You go there, and they build their own routers and switches. They write their own network operating systems. They write their own protocol implementations to do things. They've got the resources to do this. Okay, I could, Cabrillo College and even UCSC doesn't quite have that. Okay, so a lot of terminology out there associated with this stuff, with especially bare metal switches, open switches, white box switches, a lot of different terms. I want to just point you to a really good article. Jeff Doyle, you've probably heard me mention him before. It's how many of us cut our teeth on learning networking. His routing TCP/IP books. He had actually 2 volumes. And one of the books I really enjoyed was a book he wrote on OSPF versus ISIS routing protocol. Funny thing, I had lunch with him. This is a while back. Yeah, I like name dropping. I only do that because I like to know these people are approachable. They're your neighbors. And that's the beauty of this world. I don't know what, other, disciplines are like, but the world of networking, the more somebody knows and the more that they're writing books and doing all these kinds of great stuff, the more approachable they are. The more they get, the more people learn in this field, just in my experience, the more humble they become and the more willing they want to help everybody. So I mentioned to Jeff, I said, I know everybody talks about your TCP/IP book, but I liked your OSPF ISIS book even better. Although your TCP/IP book was my Bible. And he said, oh, he goes, that was my favorite book to write. He goes, that was always my favorite book. So that made me feel good. Okay. But anyway, he wrote a really good article, a blog on discussing the differences, if you're interested in all of this. Okay, SD-WAN. SD-WAN is a hot topic. Boy, I go to these conferences, especially like Cisco Live Conference, and a lot of SD-WAN stuff, basically applying SDN to the wide area network. And who better than our video to explain what that is?
These days, people expect access to information anytime, anywhere, from any device. Cloud computing and mobile devices have helped make this possible, but the networks that keep everything connected are growing and becoming increasingly complex, especially to manage. There are two primary types of networks. There is a local area network, LAN for short, and a wide area network, called a WAN. LANs connect the devices inside of your office together, while WANs connect your office to others around the world. Without the WAN, it would be like not having internet access. Sure, all of the things inside the business could talk with each other, but not with the outside world. Recently, a new technology has emerged called SD-WAN. It's the next generation of WANs and an important step in the evolution of networking. The SD in SD-WAN stands for software defined. While SD is not an entirely new concept, it has become an important focus, especially as it relates to infrastructure and networking. It really boils down to using software to make IT work smarter, faster, and at lower cost. Essentially, SD-WAN is a better way to build and manage long-distance networks. But why? How does it work? What makes it better? Let's take a closer look. Traditional WANs are made up of tens, hundreds, or thousands of routers that talk to each other over long distances. Within each router, there is a data plane and a control plane. The data plane holds the information that is being sent or received, the data, while the control plane determines where that data should go. Sounds simple enough. However, someone needs to program the control plane with rules on how to handle network traffic on the data plane. This is typically done by entering a series of commands into each router's command line interface, or CLI, by a network administrator. This can be a very manual.
I just want to mention here real quick, this is going to bring a lot of stuff together. Although it's focused on SD-WAN, you're going to see that this is one of the reasons why we're trying to get away from the whole CLI in many instances, especially your large enterprises service providers.
Time-consuming and error-prone process. Take, for example, a large retail store chain with 500 locations around the world that needs to deploy a new video application. Let's assume that each store location has a router that requires 10 commands to implement the correct configurations for the application. With 500 sites, that's 5,000 commands. If each command takes 30 seconds to execute, that adds up to over 40 hours, or a week just to deploy a single application to all the locations. And the CLI can be cumbersome and error-prone. Imagine making a mistake on one of those commands and having to hunt down that error or troubleshoot the application. Personnel and IT resources would be impacted. It could paralyze a business. Network pros try to overcome this problem by developing programming tools and scripts to automate changes. However, these tools and procedures add more layers of complexity, as well as even more CLI commands with more variables that could compound existing problems. With SD-WAN, the previous process is greatly simplified. For starters, parts of the control plane are centralized. That way, changes to the control plane can be grouped and simultaneously and easily managed across the entire WAN, using business-defined rules and, most importantly, from a central management portal. This added simplicity makes it easier to take advantage of broadband internet connections instead of relying solely on expensive private MPLS networks, which lowers costs and increases performance. Want all of your business-critical apps to take a private MPLS network between locations? Easily define that. Are social media apps sucking away the productivity of your workers? Set a lower priority or block them altogether via a rule. And once rules or policies are set, they can be automatically distributed and implemented across your organization in seconds. So, with SD-WAN, configuring new or existing networking infrastructure is much easier than the old way of fragile command lines and manual updates. Here are the 3 main points you should remember about SD-WAN. It increases agility by simplifying network policy configuration and management. It provides higher performance by intelligently leveraging multiple paths, including broadband connections. And together, these lower IT operational costs. Setting up and managing your WAN has never been better or easier, provided it's software defined. This video is brought to you by the folks at Riverbed, the global SD-WAN leader.
Imagine that. They actually have a solution for us to buy. Good video, though. All right. Okay, so again, what is SDN? It's all about, it's just, there's so many technologies and stuff out there that kind of fall into this umbrella. Again, our focus can be on the network infrastructure. So I'm going to take the next few minutes, just wrap a few things up here. I've got a few slides left, but we're just about towards the end. But hopefully this should kind of bring things home here. So configuration-based networks. Wow, a lot of protocols, a lot of configuration. And how does this, why do we do these configurations? Well, we have a business intent. We're trying to take what the intent of the business is, the policies that they want to apply to the network, and then use this myriad of protocols and configurations on a whole bunch of devices and hope at the end, this is what our network does. So the network does what we configured it to do, we hope. Okay, there's this term, I should have thrown it in here, called the source of truth. The source of truth should be what we want it to be. What are our specifications, our requirements, our intent? But really the source of truth, meaning what's really happening, is what this ends up doing. And we're hoping it's going to be close to what we intended it to do. And when do we know this? When we implement it. I mean, that's kind of been how things have been for many years, because it's got getting more and more complex. So does our configuration match what we intended this network to do? We don't know. We hope. Okay. So the network has become software, and there's this whole push and this another really big buzzword, intent-based networking. And that's basically, this is using a Cisco graphic. Their intent-based networking solution is something called DNA Center, where you interface with their DNA Center, putting your policies, what you want automated, using analytics. And this is analytics that as you implement this stuff, the network learns and adds to this analytics, and using that analytics looks at, well, what is your policies, and do I need to make any changes? So it's kind of a self-learning type of thing. And it's also what they call a single pane of glass. Not that it's just one screen, but basically having an interface, basically kind of seeing your network as a one, having everything there in front of you. Might be on several different screens, but not having to just, what's the alternative? In a lot of ways, the alternative is logging into a whole bunch of different devices and trying to get that information. We want all that analytics in one place. And if that analytics doesn't match what we want the network to do, if it doesn't, change it. Don't have us, let the system do the change. Okay, so this comes from a friend of mine, Giuseppe Cinque at Cisco. It's a good buddy of mine in Italy. This is who I go visit every year. It comes out here quite often too. But this is from his slides, and he says, the network has gone from being hardware to more software, where everything, connectivity, programmability, and security. Let me kind of go to the next slide here, but I think I've got, so it goes over this. Everything becomes connected, wireless, IoT, everything. everything becomes programmable using Python, REST APIs, SDN, NFV, DevOps, whatever we're talking about. Everything generates data in a structured format. And everything can be automated. So we're talking about Puppet, Chef, Ansible, NetConf, RESTConf, and everything needs to be secure. So he also says there's an apparent contradiction. The networking is going to be much simpler, but it's also going to require more skills from the network engineer. So the idea is simpler, meaning that it's going to take away those repetitive tasks that we do. Having to write a bunch of CLI statements and enter that into a whole bunch of devices. Okay. Writing, an access control list of hundreds, perhaps even thousands of lines of statements to implement a policy that we hope implements the policy that we want. So an analogy from music is, we know the music theory and how to play an instrument. So this is kind of what a network engineer has done over the years, right? You learn the theory, you learn networking concepts, theory, you take these different networking classes, you learn how to configure some devices, you master that technique on those devices like an instrument, okay? Now you know everything there is to be about in any situation to do with those devices. You've really mastered that instrument and just do anything you want to do it. And you know what? Because you're so good at it, you've got great perspective, you can actually learn new instruments, can apply that and learn other devices, other protocols, other things. And this is what we've become in the networking world, okay? Kind of, we're playing all these different instruments. That's not what we want a network engineer to do, to be configuring or playing all these different instruments at once, configuring all these devices. No, we want to utilize a network engineer's talents, it's their knowledge, their skills. This is what we want a network engineer to be, to orchestrate the network. And just so to give you a little, this is how I started. Yeah, that's me on the accordion. And the sad thing is, look at this clown's face. He was smiling at the beginning of all this. So that's me. That's my brother, Frank. I think we are appropriately located close to the restroom. All right. Okay, so what's going to happen from all this? Where are we going to go? What's going to stick? What's going to work? It's just, I was talking to my Giuseppe the other day about this, and I said, it seems to me this is a lot like the world of IPv6. We're waiting for when the big move is going to happen and who's going to move. So it's kind of where, IPv6 was in its infancy, or where people didn't really need to go there yet. But there are cases where, this is already happening, especially in the bigger organizations, content providers, service providers. They're already having to look at this. One more I want to mention here is, Carl, I talk about Carl, and this is from, I'll put this on the link too. This is a conference keynote from Russ White. So Russ White, I'll come back to 21. This is Russ here. This is Russ White. He's very well known. You've heard me talk about him before if you've taken my classes. Buddy of mine back east. This guy is highly regarded. I might get him to come talk one night to us as well. Here he is talking at the Internet Society meeting about SDN. He's very knowledgeable. He's on many of the IETF working groups, like for routing and other things. Written several books. Does a lot of podcasts. Network Collective, Packet Pushers. He's got a new one out called The Hedge. And very, he's really good. He's very opinionated, but not in a bad way. If you have a different opinion, he's fine with that and he'll listen to it. I'll leave this. The link is on Canvas. This is way back from 2014. But the reason I bring it up is because, man, these are the Carls. I'm glad the new generation of network engineers that is coming is wonderful because it's so much more diverse, especially in the United States. It's a bunch of old white guys. And it's so nice to see now in my classes for at least the last 10 years to see so much great diversity. And I don't say that for diversity's sake. I say that because, darn it, we need it in this industry. We need ideas from everybody. I talked about a little bit in one of my other classes this week about how protocols get developed. There isn't a scientific best method to do everything. I'm on the reading list for stuff done in IPv6. I'm not on the working group. I just get all the emails, and the different opinions on how to do something is vast. And that's been the world of protocols. There's a book called Protocol Politics. And what I'm getting at is there's not one great way of doing things. We've got to start thinking outside the box, and it's going to take people like all of you to get us there, either, or to do that within your organizations. And you're all great because you're all learning all this great stuff that I wish, I was back in school learning myself. So anyway, I will get everybody access to Canvas. Our next class will be in 2 weeks. All this is always subject to change what I'm going to be doing, because I'm like, oh no, I need to do this. But 2 weeks from tonight, my goal is so far to talk about JSON, YAML, and XML. Okay. How are we doing? Everybody all right? I started the recording, right? Or we're gonna have to redo all of this. Oh, no, okay, we're good. All right, I'll let you have the rest of your night. Thanks for hanging out. I mean, it's nice having live audience. Watching the recording, thank you for those watching the recording. I appreciate that as well. But it's also nice that I actually see people, faces, and videos that I get to see. So it makes me feel I'm talking to somebody besides my dog who's right there looking at, who's still asleep. All right. Well, thank you very much, everybody. I'm going to go ahead and stop the recording. There we go.
Thanks, Rick.